sklearnnaivebayesMultinomialNB. Description: Multinomial naive Bayes is a probabilistic classification algorithm that is commonly used for text classification tasks. It is based on the Bayes theorem and assumes that the features are independent of each other given the class inputs X. This is a 2D array representing the input features. Each row represents a data point, and each column represents a feature. Y. This is a 1D array representing the target labels for the data points in X. The length of Y should match the number of rows in X. Outputs. Self. This is the fitted multinomial NB object. It can be used to make predictions on new data points. Steps. Training. The algorithm first calculates the prior probabilities of each class. Then, for each feature, it calculates the conditional probability of that feature given each class. These probabilities are stored in the fitted multinomial NB object. Prediction. Given a new data point, the algorithm calculates the posterior probability of each class given the features of the data point. The class with the highest posterior probability is predicted as the most likely class. Metrics. Accuracy. The proportion of correctly classified data points. Precision. The proportion of correctly classified positive data points among all data points predicted as positive. Recall. The proportion of correctly classified positive data points among all actual positive data points. F1 score. The harmonic mean of precision and recall. Visualization plots. Confusion matrix. This plot shows the number of true positive, true negative, false positive, and false negative predictions. ROC curve. This plot shows the trade-off between true positive rate and false positive rate for different classification thresholds. Fine-tune parameters. Alpha. This parameter controls the smoothing of the probability estimates. A higher value of alpha corresponds to more smoothing, which can help to avoid overfitting. Fit prior. This parameter controls whether to learn the prior probabilities of the classes from the data or to use a uniform prior. Uncertainty methods. Confidence scores. These are the posterior probabilities of each class. They can be used to estimate the uncertainty of the predictions. Challenges and fixes. Challenge 1. Data sparsity. When dealing with text data, it is common for some words to appear very infrequently, which can lead to zero probabilities for those words. This can cause problems for the multinomial NB algorithm. Sample use case that resulted in challenge 1 when using multinomial NB on a dataset of customer reviews. If a particular word appears only in a small number of reviews, it might have a zero probability in some classes, leading to inaccurate predictions. Fixes to challenge 1. The alpha parameter can be used to address this problem by smoothing the probability estimates. Challenge 2. Zero probabilities for unseen words in the test data. This can happen if the test data contains words that were not seen in the training data. Sample use case that resulted in challenge 2. If a new product review contains a word that is not present in the training dataset, the multinomial NB model will assign a probability of 0 to that word, leading to inaccurate predictions. Fixes to challenge 2. The alpha parameter can be used to address this problem. By setting alpha to a small positive value, the algorithm will assign a non-zero probability to unseen words.